Alright, so welcome back to the channel, guys and gals. I'm still Pontus, and today we're going to focus on the Visual Studio Debugger. Let's do it. Alright, so before we get into anything complex, let's start with the absolute basics here. So I have an empty console application here, and I'm going to add some boilerplate code to it, just so we have something to step around in the debugger with. And let's call something called, let's do a foo. Call a foo method, and from that thing we'll call a bar method, and inside bar let's create a string with an exclamation mark, and that'll be fine. So if we were to run this with Control F5, we would get something like this. Press any key to continue. So this Visual Studio have added this for us basically. Press any key to continue, and it waits for us to basically, it's a console read key here. And if I hit enter here, everything is basically completed and the program shuts down. Now, if we were to run this with a debugger, hitting F5 or pressing start, the application would just start and then end. So when we're doing actual debugging, we need to set a breakpoint to tell it when to break. So I'm hitting F9 here, which means toggle a breakpoint. And now that we have one, we can go F5 again, and it'll stop at our breakpoint. So the little yellow arrow here, that's basically, that's our playhead. So that's our playhead. So that's telling us where we are right now. And if I go F11, we're basically saying step into, and step into means go to the next line. It doesn't make a whole lot of sense until we're at an actual method call. If I go F11 here, we're stepping into foo. Now, if I don't want to step into bar, I can go step over, which would be F10. So bar have executed, but it's just that we didn't bother to basically go into it with the debugger. So this playhead over here, this yellow little arrow, we can drag and drop that thing and say, yeah, take me back over here. And if I feel that, okay, maybe I want to go into bar this time, F11, F11. And let's say bar is a long method and I don't want to, go through every line of it. I can go Shift F11. So that basically means step out. So Shift F11 takes me back to the calling row, the calling line, and we basically can do it again. So now I'm back at foo, and we can just drag that thing again. So the playhead is now at the point where we basically just initialized our I variable. Notice though that the actual value of it, if I hover over this I, it says 13. So that is still, state is basically remained. So if we do some F11 here, we can see that, yeah, I value has now changed. It basically at 16 now. So now let's have a look at these little windows here, the call stack and the locals and the autos and whatnot. So let's start with the call stack window. So we're just about to go into foo, the foo method here. So I'm going to hit F11 for step into. And as I do that, monitor the call stack here, you can see it just added one more call. We're now in main, and if I hit F11, we're in foo. And if I hit F11 again and go into bar, we see that, okay, first we were in main, and then we were in foo, and then we were in bar. So this is a stack, like a stack of papers, so that the latest one will be on top. And this is very interesting because we can double click any of these and just go into basically see where did we enter this? Where was the call that took us to this level in the stack, in the call stack? And it's a good way to find out, like, okay, how did I arrive at this point? So that's really useful for finding bugs. And of course, as soon as we leave a method, the call stack is reduced by 1. So it pushes and pops stuff into the call stack until we're basically at 0. The application begins at 0 and it ends in 0. The locals and the autos window is basically the same thing. Autos is just a subset of locals. So locals shows us every variable in scope, every local variable in scope, and autos shows us just the variables we're using on the current line or on the previous line. So autos it's just a subset basically of locals. Now watch is interesting. If we want to monitor a variable, even if it's not in scope, I can just hit enter, and we see that the value is 16. And if I now go into F11, we can see that, okay, oh, sorry, we actually left the application there. I'm going to hit F11 again. Notice that my watch is still active here. And I'm going to go into foo here. So now we can see our I is grayed out. So it's basically showing it, yeah, it's 13. But anytime it would change, it would turn red. So we're still monitoring that thing to see when does this variable change. So if I drag this playhead back to our breakpoint there and go F11 again, we can see that, okay, the value has changed. It's 14, and basically it's turned red to indicate that, yeah, it's changed. So watches are really interesting. And as you noticed, when we stopped the debugger and start it again, it keeps track of whatever watches we added to it. So what else? Yeah, the immediate window is an awesome one. So the immediate window gives us almost like a scripting language. We can just talk to the variables, modify the variables, and basically interact with the state of our program here. So if I go I, hit enter, it says I is 14. If I go I equals 20, it says 20. And we have actual IntelliSense here, so we can go console.writeLine, and I'm going to write an exclamation mark on the console. Not sure if you can see that, but it's actually an exclamation mark on our program there. So yeah, the immediate window it's a really powerful one. I'm going to do something here that I'm not sure, it's not super intuitive, but it's really interesting to know that it actually works. So here we have post execution on this line here. So that means I can basically go and modify this code now. So I can say I equals 10 again. So this feature is called edit and continue. And I can do whatever I want now. And I can just run F11 and see that, yeah, that code has now been injected into the actual program. The thing that makes that not maybe super intuitive is just that often when you're running a program, you get something like this. So since we're in a console application now, it's not super easy to demonstrate. Maybe if I go console read key, so I actually pause the execution of the program here, and then I'd go I++ again. So I'm going to place a breakpoint over there. And now I'm going to hit F5, which basically tells the compiler run to the next breakpoint. And in this case, since we have a console read key, it's going to wait for us for the actual user to enter a key. So I'm going to enter a key into the program, and there we're back again. And while we're in such a state, I'll do it again. While we're in this state, so notice now we're not actually, we haven't paused execution, and at this point we cannot edit the code. We get something like this. Changes are not allowed while code is running. So the thing is just, you need to be in debug mode. Now we can do whatever we want. And just hit F11 and basically go on. So edit and continue is an awesome feature. You just need to make sure that you're actually pause the execution in debug mode. So Visual Studio 2017 also has this nice little feature where we can just hover over any line, and we get a very discrete little playhead over here, and we can hit run execution to here. So basically it's like placing a temporary breakpoint and hitting F5. You might also have noticed this little less than 1 millisecond elapsed here. So if I hit F11, it tells me that less than 1 millisecond elapsed between the last line and this one. So that's basically an approximation of how expensive was the previous line to execute. So that should give you a good indication of was this a heavy or a lightweight operation. So let's hit Shift F5 to stop this debug session here. And let's say I want to start a debug session from this specific line here. So there's something called run to cursor. Control F10 will basically do this. So if we hit Control F10, it'll start an application or start a debugging session at this very line that we're standing on. So that will help save us the trouble of hitting breakpoints all the time. Of course, if I want to start a new debug session from the first line, we can always, from design time, basically when we're writing code, we can always hit F11 and it'll basically start the application and stop at the first line. Okay, so let's have a look at some conditional breakpoints. So I'm going to wipe some of this code out and do a little for snippet here. Let's say I'm going to loop that thing 5 times. And let's put a breakpoint at the first line here. And if we right click on it, we can see that we can disable the breakpoint, basically making it okay, it won't never be hit. But we can also do something like conditions. So this is quite powerful because it's not always we want it to break 100% of the time. So here we can do something like, I want like a hit condition, like a hit count, sorry, like the third time it's called, I want it to break. Or I can be more specific to do something like I equals 3. When I is 3, then I want this thing to hit. And we can also add an action here. So we can say something like log a message to the output window, something like I is now 3. And notice now that this breakpoint has got another shape here. So this continue execution is a little tricky one. So this basically means don't break. If I uncheck that thing, now it's breaking. So continue execution basically toggles that. So now if I close this and hit F5, so now the hit point broke and I is now 3. And if we look at our output, it says I is now 3. So that's kind of convenient. So we can also delete all the breakpoints. Control Shift F9 will just remove everyone. So all the breakpoints will now be deleted. So I just wanted to mention a little more about object tracking, because something that I found can be quite complex sometimes is something like this. Let's say we have a number of objects here. Let's say object 01 equals, let's say it's a string test. So basically we're going to track where are these objects pointing to. So I'm going to create another object, 02, but that thing is pointing at 01. And maybe we'll do an 03 as well, pointing to 02. So I'll put oh no, I won't. I'll just go boom, run to cursor. And so if I want to find out now, where are these stuff pointing? So let's say we go to the locals here and have a look. We say 01 test, 02 test, 03 test. And I can right click on that one and say make object ID. So basically now we can see that, okay, $1, that's our alias for this actual object. So what it's actually pointing to. So, and here we see that 01, 02, and 03 all have the same values, and they're all pointing at $1. So there's just one object actually on the heap here. So that thing can be quite interesting, and it's also useful for tracking, you know, when some object goes out of scope, because it's, you know, the garbage collector comes and sweeps it away. So yeah, that's a nifty little feature. We might also want to mention something about return values. So I'm just going to drag the playhead up a bit and call foo here. Oh, actually, let's do something like this. Let's call a new one called foo bar. And I'm going to say something like int I equals. Generate that method for us. So this method is supposed to return an integer, right? So I'm going to return 100. And I'll just hit F11 here. So we come to foobar, our foobar call. And if I step into that thing, and if I now hit F11, so I'm actually leaving foobar, here we can see in the locals window, it's saying foobar returned 100. So that's quite nice too. You can always find out what was this method actually returning. If you're in the immediate window, there's also a little variable for that. So you can go something like, I think it's $return value. So $return value, yeah, says 100. Okay, now let's have a look at some exception settings. I'm going to go Control-Alt-E here. So here we open up the settings for this in Visual Studio. When should stuff, which exceptions should cause the debugger to break, for instance. So we can see here common language runtime exceptions. So basically break when thrown. So that means that if we go, let's do something like this. Of course, if we have an unhandled exception, the debugger will always break. And that's basically what we want, because if the application is crashing, we want to use the debugger to locate the bug. But let's say we have something like this. We have a try catch, and we catch that. So we're not rethrowing the actual error here. So I'm going to try something like throw new argument exception. And I'll copy the whole try catch thing again. And I'll hit F11 to start the debug session from the first line. And yeah, if I'll just step over here, so throw new argument exception, so boom. Value does not fall within the expected range. Okay, so that's perhaps not the most intuitive exception to throw right here, but anyway. So here we can see that we can actually stop the debugger from breaking here. So we can say break when this exception is thrown, except when it's thrown from this very application. So now when I F11 here, it's throwing, but it's not breaking. And that stuff is quite interesting, because that means if we open up exceptions again here, now it's added a little extra detail over here saying argument exception, well, yeah, break if the module name not equals to console application 1. So basically that's a good way to indicate in your application, like, yeah, maybe you don't want any of these to break, or maybe you want all of them, and maybe you want to make some exceptions. So yeah, that's quite flexible. Okay, so finally, let's have a look at attaching the debugger to a separate process. So maybe we haven't actually launched the application from Visual Studio, but we still want to attach the debugger. So I'm actually going to get rid of this code and do something like console.read key, just to pause the execution. And we can, let's do a write line. And now I'm going to start this application with Control F5, so I'm not actually debugging it. So the application is running, but it's not attached to the debugger. And now we can go into debug and attach to process, Control Alt P. And we have a nifty little filter here. We can go console app1 was the name of my application here. Just double click that thing, and now we basically attached the debugger to that process. So if we bring up the application again, type something, boom, we're back at our breakpoint. Okay, so that's basically what I was intending to talk about today. So if there's anything new you want me to talk about, any new videos, just type it down below. And as usual, you don't have to like, you don't have to subscribe, you just have to have an awesome day. See you guys.